going to be solving questions related to probability theory. Obviously, there's going to be a lot of questions that I'm doing this for self practice only. Again, the mantra here is self practice. Okay. Now, okay, that's the first question is probability of A defined from classical definition of probability is any real number lying between 0 and 1, both inclusive. So the answer to this would be false, because the definition of probability does not say about every real number or any real number that is between them. So it is not a complete definition. Probability of an event may exceed unity. We all know by definition that probability lies between 0 and 1. So false. The probability of obtaining a 3 or a 6 in a fair die is 1 by 3. So 2 upon 6 by 3. So this is true. For any two events A and B, A minus B is equal to probability of B minus A. I think this would be false, because that would mean probability of A complement equal to probability of B complement, which should not be true, assuming that if A and B are my only the thing in my sample space. In any other scenario, definitely not. I can only say this in the case when I know probability of A is equal to probability of B most likely, and in that case it would be 0. I don't know, something like that. So but whatever, that makes us that. Okay, now, okay, so this is not going to come right. Okay, so wait, I'll tell. Fifth part is if events A and B occur together, then which I think if A and B occur together, so probability of A is equal to probability of B. But then how does, okay, if events A and B occur together, then probability of A is equal to probability of A minus B. True or false? The statement, it says it's, my book says it is true. Yeah. If they mean A occurs, then B is a subset of A. That whenever B happens, A also happens. If that is the case, then A outside of B is this. Wait, let's construct the Venn diagram. Wait. So this is how this goes, right? This is my A, this is my B, and this is my A, right? Now we know B is a subset of A. then we are saying mm, this is what we have said. Okay, if events A and B. Oh wait, okay. It was if events A and B cannot occur together. My bad. And no, my bad. And you invested yourself in this with me. Sorry. So this is wait cannot occur together. Then probability of A is equal to probability of A minus B. Wait, let's now reconsider this. Okay. Now if A and B cannot occur together, A intersection B is phi. Right. A intersection B. Then probability of A to probability of A minus B will also be probability of A. That means it is true. Yeah, so it is true. Yeah. My bad moment, I'm sorry. Okay, now the first question, that sixth part here is yes, if A probability of A is equal to probability of B, then A and B are same event. Yeah, this should be false. I'll say false. Because it's not given. It could be that they have still similar probability and yet they are different events. Okay. If event A is contained in event B, then probability of A or B is equal to. This is why we just discussed something like this. So it is saying A is contained in B. I think this is true. Let me check. Is this true? Wait, this is seventh part. Yeah, this is true. So yeah, this is true. Okay, if A denotes that a student reads in a college, B denotes that he plays football, reads, okay, and plays football, then probability of A intersection B is 0. I can't say that for sure now, can I? A person can read and play football. I think it would be false. Yeah, it's false. Correct. Okay, if event A implies event B, then probability of A is less than probability of B. B is a subset of A here because A implies B. If A is happening, B is happening. Okay, wait, A would be subset of B because yeah, it is a true case scenario. Yeah, it is true. Okay, probability of B given probability of A when A is an impossible event. If A is an impossible event, then probability of B can be defined. I don't think so. Yeah, false. If A cannot happen, then the whole point of B happening is how can it be happening? Two mutually exclusive events with positive probabilities must be mutually independent. I have no idea. Two mutually exclusive events with positive probability must be mutually independent. True or false? Mutually exclusive means this. Mutually independent means this. Thus, yeah, mutually independent events cannot be mutually exclusive because mutually exclusive would mean zero. No, okay, false. Okay. Probability of B given A is B. I doubt. Wait. This is true. Okay, let's then. If probability of B given probability of A is equal to probability of B, then A and B are independent. True or false? Probability of A intersection B. Yes, they are independent. Okay, alright. So this is a good proof. So yeah, this is true. Okay. Very genius of it. Independence means over probability of A, I can cancel it, which is the point. Probability of A is equal to 0 implies probability A is an impossible event. Wait, let's figure this out. What is an impossible event? Wait, the question right now is another. Okay. If probability of A is equal to 0 implies that A is an impossible event, true or false? My book says it is false. Impossible, even it can never happen. Okay, in probability theory, some events have zero probability but can still occur. Okay, it will be false. Alright. The probability of getting head and getting tail from a throw of any coin are same. I think this will be false because only from an unbiased coin is it true. Okay, if probability of A and B are okay for any two events, probability of A union B is less than equal to probability of A. Not always. A. Yeah, this is false. Probability of A not equal to 0. Probability of B not equal to 0. Probability of A, probability of B given A. I think this can be true. Yeah. Somehow applying this and making both sides equal if is a possible scenario here. Okay. Also, the one piece of information that I don't know right now is definitely a concern, but let's see later. The probability of getting a heart in drawing a card from a good deck is 1 by 4. I think true. Yeah. Fill in the blanks. If events A and B are complementary to each other, then probability of B is equal to wait, if events A and B are complementary to each other. Here complementary means something else than the usual meaning that we take. So probability of B is equal to, the book says probability of A complement. I don't know. I'll figure this out later. You can Google it meanwhile if you're at that juncture. A probability of A given B is 1 by 4. Probability of A complement B would be, I think, 1 3 by 4. Yes, it's 3 by 4. Okay. Probability of A is 1 by 4. Probability of B is 1 by 2. This would be the highest possible value is, given that there is no intersection between them, I'll add them. This is my highest possible value because I'm not subtracting anything right now. So this will become 4, this 2, 1, 3 by 4. This would be my highest value, assuming that there is no interaction. Okay, probability of A1 is 0.2, probability of A2 is 0.1, probability of A3 is 0.6. They are mutually independent. Okay, that means there's no intersection. A 0.6 is the answer. Oh yeah, it will be 0.06. I have to multiply it here. I was simply adding that would not be. Multiplying is the important, so I'll have to multiply 0.2 into 0.1 into 0.3, and then I'll receive the answer. Okay. If probability of A is equal to half, probability of B is equal to 1 by 4, then the highest possible value of probability of A intersection B is, okay, we just did this, right? 1 by 2 plus 3 by 4. The highest possible intersection between them shall be 1 by 4, then I think. Or else 3 by 4 they're already taking. They cannot definitely take more than that. I don't know. Let's ask. Okay. If probability of A is equal to 0.5 and probability of B is equal to 0.2, 5, then the highest possible value of A intersection B is. The highest possible value would be, okay, so this is the formula. We will take the probability of small event. Wow, this is something to remember. So it will be 1 by 4 because of this. Who would have thought that this is a logic that exists? If it weren't for these problems, I'm grateful only. If events A1, A2, A3 are exhaustive and mutually exclusive, then probability of A1, A2, A3 is equal to, I think, yeah. Yeah, correct, two things. Okay. Total number of conditions for independence of three events is. Independence condition is, what is the 4? Probability of A intersection B I don't know, it says probability of, sorry, total number of conditions for independence of three events is. Yeah, it's right to assume so. The 4 conditions. Yeah, the probability of having no head from 3 rows of an unbiased coin is 7 by 8. Sorry, it would be 1 by head. I thought, yeah. Okay, yeah, that would be 1 by. Okay, if probability of A and B are independent events, probability of A is this, probability of B is this. Oh, probability of A minus B would be. Let's construct a box. This is my box. A is 0.5, 0.7. How they it will be. I don't know. If A and B are independent events and probability of A is equal to 0.5 and probability of B is equal to 0.7, then probability of A minus B is. Okay, so this is the. That makes more sense than what it was making. So yeah. That's right, 0.15 is the thing. Okay. Now, okay. Can I? Oh, wait a second. Hold on. You can. Yeah, okay. Let's start with C only. The probability of getting ahead each time when an unbiased coin is tossed twice would be a very specific case we are in. This is 1 by 4, I think. We are talking about HH, not HT, not TH, not TT. I think it should be A. It is A, yes, okay. Two cards are drawn at random from a pack of 52 cards. The probability of being aces, I'm drawing two cards from a pack of 52 cards. So the first time I draw this 56, 54 into 52. Then the second time there's 3 upon 51. So this will basically become it should be this, right? It is this, okay. 3 letters are written and put at random inside 3 addressed envelopes. The probability of the letter to go into right envelopes is okay. So each letter has only one right outcome. So this is the only probability that it can go through with. The probability that is going to right envelopes would be it happening 3 times. And that's what I'm saying. This is the probability that all letters go into the right box. The answer is this. Wait then. What have I done wrong? There are 3 letters are written, put at random inside 3 addressed envelopes. The probability that the letters go into right envelopes is I don't know, wait, let's see. 3 letters are written and put at random inside 3 addressed envelopes. The probability that the letters go into right envelopes is so this is my total number of A's. Okay, wow, okay. Okay, this makes sense right now. Okay, moving ahead. The chance of throwing a 6 in first only of 2 successive throw of a fair die is the chance of throwing a 6 in first only of 2 successive throws of a fair die is so the only time that I'm throwing a 6 is this time, and the second time I'm choosing not to throw a 6. It should be B. It is B. Okay, the probability that a marksman will hit a target is 1 by 5. Then the probability that of having at least one hit in 10 shots is will hit a target is 1 by 5. At least one hit would mean that probability of not hitting the target at least once. This would be probability of not hitting. But in 10 throws, we are talking this about now. Okay, so in all 10, we are saying probability of not hitting. Yeah, okay. One minus probability of not hitting the target all 10 times. So this would account for if he had gotten one. So the probability essentially that we are subtracting is about 0 only. If A1 and A2 are such events that probability of A1 is greater than 0 and probability of A2 is not equal to 1. Okay. I will skip this. This is beyond my range though. Just in case anybody knows this. This is the answer. Okay, a number being chosen at random from first 120 natural numbers. The probability that the number is a multiple of 5 or 15 would be. Mm, or we are also putting a union. So I can put basically 15, 30, 8. Mm, wait. Okay, this wouldn't make sense. No, no, no. I don't know. No, wait. Okay, wait. I'm not close to any answer right now. Okay. A number is being chosen at random from first 21 natural numbers. The probability that the chosen number between multiple of 5 or 15 is, so it will be 5 plus 15. That would mean I will include everything that is 5 also. So it will be 24 by 120, which will be 1 upon 5, and that's how it will be 1 by 5. Yes. The probability of event A occurring is 0.5. The probability of event B occurring is 0.3. If events are mutually exclusive, then probability of neither A nor B occurring is event A occurring is 0.5. Probability of event B occurring is 0.3. Yeah, exclusive. D. Yes, okay. Okay, if A and B are two events, probability of A union B is 5 by 6. Probability of A intersection B is 1 by 3. Probability of B complement is 0.5. That means probability of B is 0.5. Now first what I think is to find from this is probability of A. Wait, that would be now. Oh, they are independent, are they not? Wait. They are independent, yes, okay. If the first two identical boxes contains 4 white and 3 black balls, and the second one contains 6 white and 2 black balls. One box chosen at random, and a ball is also taken out from it at random. The probability that the ball is white is the probability the ball being chosen, then the ball would be first box chosen would be 4 by 7, second box chosen would be 8 by 6. Yeah, it will be this only.